We're good? Perfect. Okay. So, Borouge is part of a large global polyolefins family. We are a joint venture between the Borealis company, headquartered in Vienna, and the Abu Dhabi National Oil Company here in the UAE. So Borouge was formally started in 1998. And the idea was to bring European technology together with feedstock from Abu Dhabi to create a range of polyolefin solutions for different industries. So our primary focus is supporting infrastructure in the region, particularly energy and pipe, of course, together with packaging solutions and automotive. When we started in the first plant in 2002, we were operating at roughly 600,000 tons of polyolefins. And with the startup of Borouge 3, we're now at 4.5 million tons of polyolefins. What is interesting for you guys here is that Borouge 3, for the first time, included a dedicated investment in wire and cable. And so we started up in May 2016, a high-pressure LDPE reactor. It's a key component for the production of wire and cable installation systems. And we have a capacity there of 350,000 tons of LDPE. So, quite a significant capacity. Just for interest again for colleagues from the Middle East region, of course, Borealis itself is owned partially by Mubadala here in the UAE, as well as the Austrian oil company OMV. So I want to give a kind of slightly upbeat perspective of what lies in front of us for the wire and cable industry. And of course, I think there's been a lot of discussion about quality and the challenges of the industry. But I think, if we look at forecasts, we see a changing landscape, of course, with the growth of renewables. But we also, most importantly, see significant investment in both generation as well as the T&D assets to move power to load centers. So I think we can all sleep easier in our bed knowing that there is great opportunity ahead for all of us. And that's, we in Borouge and Borealis remain committed to the industry. In the last decade, we've invested more than $1 billion in wire and cable. This includes a complete renewal of the reactor in Sweden for production of XLPE solutions in Europe, as well as the investment in Ruwais with more or less a carbon copy of the setup in Sweden. I think you'll really appreciate this is incredibly an actual photograph of our compounding facility in Ruwais. It's kind of like a Mondrian painting, right? So I don't know who did that, but a very interesting approach to an industrial complex. So again, the concept with Borealis is to, of course, to share technology, to share solutions, and we, of course, have invested significantly in Ruwais to set ourselves up with a plant that has a capability to produce extra high voltage solutions in the Middle East region. Before getting into the XLP story, I just want to touch on broadly the areas of the wire and cable market that we're involved in. So, of course, a number of you over the last couple of days have talked about high voltage DC. I think it's fair to say that in extruded systems, the Borealis organization is really at the heart of this business in terms of delivering insulation systems that have facilitated the growth of extruded cable systems, particularly related to European wind farm development. Many of you will have seen that we've recently qualified our DC extruded system at up to 640 kV. So this is an area of the business that we're really focused on and continue to develop with our partners. again associated with the growth, the incredible growth of renewables that we're expecting, particularly in China and India. We've been developing specific photovoltaic solutions, again based on our core technology platforms of Visico. And this is really a new development that we've been rolling out in the region to key partners, to tie ourselves to the incredible growth that we are expecting in PV. Energy distribution is probably the most important for us, and our investment in Ruwais was initially designed to give us the capability to bring medium voltage XLPE to the market, produced locally in the region and no longer exported or no longer imported from Europe. So at startup of our plant, we were producing within the first month LS4201R, again for local partners here in the Middle East, as well as China, India, and other developing markets. Our ambitions from Borouge remain to move forward in terms of voltage classes, to support again the growth of the business for cable systems, the ambitions of our customers to move into increasingly higher voltages. And again, with the design of the plant in Ruwais, we anticipate in future years achieving the sort of high quality levels expected from Borealis and moving into high and extra high voltage. Let me roll on to the final one. So LV distribution, again, an incredibly rapidly growing opportunity for us, particularly in developing countries. And we have, again, from our assets in Ruwais, had our first successful test run for Visico low voltage material. So again, we'll be coming to the market, to our key customers around the Asia Pacific region with low voltage solutions, again, produced in Ruwais. But what I wanted to really talk about today was XLPE and our differentiated approach to XLPE in terms of quality and performance. Lots of people over the last couple of days again have talked about the need for quality, but also, I think interestingly, with the EDF presentation yesterday, talking about the need for high productivity, long length cable solutions. And this is really where we're focused in. So Borlink is the overriding brand that we use to link together the key components of an XLPE dielectric system. And Borlink really stands for different things. It stands for the technology itself, which is closed loop systems from gas feedstock through to finished XLPE in a single integrated plant. Incredibly important. We're one of few companies in the world that are able to do this on an industrial scale. Of course, 50 years track record and our experience in the development of XLPE right from the onset of the industry, I think is again a key value captured within Borlink. Our technology platform of low scorch, super pure XLPE, again, is an important development. It's worth noting that the investment we made in Ruwais produces only low scorch XLPE. So we're completely focused on bringing the latest technology, high productivity solutions to the market. So how are we doing this? Well, the LDPE platform in Ruwais, it's difficult to capture the sheer scale of this, but just to give you some headline numbers, the tubular reactor is 3 kilometers long and operates at a pressure of 2,800 bar. It's contained in a concrete containment vessel. As you can imagine, a failure of such a plant would be a catastrophic explosion. So, it's an incredible engineering feat to build such a plant. But we feel it's essential to be able to produce the cleanest and most consistent XLPE through a process of closed loop, gas, high pressure, no catalysts, limited, zero hangover residues from catalysts, giving us the capability to really deliver the highest levels of cleanliness and consistency. And I think it's important to note that this was probably the most successful startup of an LDPE reactor anywhere in the world historically. And we've been able to, within 12 months of operation, achieve the sort of consistency and cleanliness which is allowing us to move into high voltage solutions much, much faster than we ever anticipated. So for those of you who are chemists, I'll try and explain this. I'm not a chemist. I'm one of the few people in Borouge who's not a chemist. So I will, though, try to do it some justice. So the classic cross-linked XLP solution, containing peroxide as the cross-linking agent, typically when you extrude, cure, you have one cross-link per each peroxide bond. So that has been the industry standard since the earliest development of peroxide-cured solutions. What we developed within Borealis and Borouge is the SuperCure platform. So we actually make a modification to the base resin within the reactor stage. So again, this is not a compounding exercise. This is actually, again, within the LDPE reactor, we add a vinyl addition to the structure. And what that actually allows us to do is to create multiple cross-links for each peroxide bond. And this brings a number of advantages. Number one, and of primary importance, is low scorch. So the ability to run longer campaigns without stopping and cleaning down. It also has a side impact, particularly on high voltage solutions. Again, because we are able to reduce the amount of peroxide in XLPE, you have a lower degassing burden on high voltage solutions. And again, what we've seen through experience with partners and customers is broadly a 20% reduction in degassing time for the same level of methane left within the cable itself. So not particularly advantageous on medium voltage cables, of course, which you don't force degas, but incredibly advantageous when you're talking about large dielectric walls, high voltage cables of 220 and above. So here, again, just to reiterate the point on low scorch and degassing burden, and I want to give an example on the scorch side. So some of you will have seen, I hope, one of our cable partners in China, who is a key player in the submarine business, Hengtong Subsea, have announced over the last 12 months 2 world records. Firstly, on a 220 kV AC submarine cable, they produced a little over 30 kilometers of 220 kV core on a 26-day campaign, unbroken 26-day campaign with LS 4201 XLPE. I think that's an incredible achievement. That was successfully tested and commissioned and in service now, and it's a connection from an offshore wind park off the east coast of China to the mainland. Subsequent to that, I think 2 or 3 weeks ago, Hengtong further announced an 18 kilometer long single unbroken length, no factory joints, 500 kV AC cable, also for the grid in China. Again, we believe a significant world record, reducing the need for factory joints. So we have a strong belief that low scorch XLPE is the way to go, and it's the only solution that we are producing in Ruwais for medium and high voltage applications. So let's look at a little bit how Borouge are going to move forward in the XLPE business. So we are going to take a slightly different approach to Borealis in the market. We have a broader range of solutions from Ruwais, and we've made a conscious decision to change the way that solutions are recommended to customers. So for the first time, we're going to be talking in our data sheets about maximum AC stress that is applicable for the solutions that we're providing to the market. And we're really trying to encourage here, obviously, the exploration of compact cable solutions as well, to encourage, really the applicable use of XLPE. One of the challenges we have, and I think it's not just here in the Middle East, is that when you are the producer of high quality, consistent XLPE, so your customers are often encouraged to stretch the application a little beyond what is actually recommended. And so here what we're trying to do is encourage customers to use the right solution for the right application. One of the things that we have implemented as well is to change the way that we provide information to customers regarding contamination, because there's often a misunderstanding about the contamination data that we provide. And when we provide data that indicates that there are 0 contaminants in XLPE, particularly medium voltage solutions, that often simply, that information is often misused, and medium voltage XLPE finds its way into high voltage applications. And this is something we really want to discourage. So that's why we've sort of broadened our range of solutions to capture what we believe are a solution for every application based on stress as well as voltage. And here's sort of, again, just to recap on compact cables. So again, the idea here is that based on stress, we ensure again that the cable designers have material solutions that allow them to explore compact solutions as well. And again, an exercise we've been working on in China with State Grid is to enhance the specification of 110 kV cables and 220 kV cables in China, to bring down the wall thickness, which hasn't been reviewed in China for almost 20 years. So again, to give you an example, to bring 110 down from 17 millimeters today to around 13 millimeters of XLPE, and similarly at 220 to bring down wall thickness from 24 to 21. And this is being done again with Borlink XLPE solutions as well as our semicons, to ensure the right solution in the right application. I think that's me done. Thank you very much for listening, everyone. Questions? Thank you very much.